Hello and welcome to Distance Learning Week 2. This is going to be the first lesson of Week 2. Hopefully you were able to complete everything in Week 1. If not, contact your teacher and hopefully we can get all that figured out. But let's go ahead and begin. Lesson 8-1, naming arcs and their measures. Our learning target will be I will identify and name the different arcs of a circle and find their arc length. Go ahead and fill out the notes. The circumference is the measurement of the perimeter of a circle. So think of the circumference like the perimeter of the circle. We just call it something different, which is the circumference. And what is the circumference? So a part of the circumference of a circle or curve is called the arc. So think of an arc as a piece of the circle, which means the piece of their circumference. Now, we have three different types of arcs. Okay, so the first one is going to be the minor arc. Now, the minor arc is an arc whose points are on or in the interior of a central angle. So look at the diagram over here. The central angle is going to be the angle created right there in the center. So from the center of the circle, two radii make a central angle, which is x. Now, the minor arc is going to be AC. So AC is going to be the minor arc. And the reason why it's called minor arc is because it's less than 180. And we use two letters to name the minor arc. So AC. Remember, less than 180, minor arc. So now we have the major arc. The major arc is an arc whose points are on or in the exterior of the central angle. So then look at this. Here's our major arc. We're going to go from A to D to C. And notice that the major arc is greater than 180, but less than 360. So, and you use three letters, A, D, C. Put a little arc on top. Okay, so it's greater than 180, but less than 360. Use three letters to name it. And then finally, the last one is what we call a semicircle. And this one is if the endpoints of an arc lie on the diameter of a diameter, the arc is a semicircle. So look, the semicircle is exactly 180. Notice that it's half of a circle. And then what you can tell as well is we also use three letters. So E, F, G. Semicircle equal to 180. So let's go ahead and see if we can apply these. Oops, never mind. We have to fill out some notes. Okay, so right here. In a circle, the length of the arc is a part of the circumference. So the length of the arc is a part of the circumference. And remember that the arc measure is equal to the measure of the central angle. And we'll take a look at that, what that means a little bit later on. But let's go ahead and answer these questions over here, 1, 2, and 3. All right. So let's get started. Name 8 minor arcs. Now remember, the minor arc is this one up here. So we're going to use only 2 letters for naming all of these, okay? And remember, it has to be 2 letters. It also has to be less than 180. Okay, so 2 letters, less than 180. Got it. So let's do 8 of them. What about RQ? That looks pretty small, less than 180. RQ. Perfect. Okay, now what about RU? So look at this. I can go from R to U, even though I skipped through Q, but since it's a minor arc, I only need to use 2 letters. I can skip letters however I want, but I want to go from R to U, which is still less than 180, so that's fine. Okay, what about, all right, what about SU? Look at this, so let's go down here, look, SU. Okay, I skipped T, but it's still less than 180, so I can use 2 letters. And then what about UT? Look at this. I can just go do this one, right? That one's small. So UT. Okay, less than, oops, I'm gonna erase. All right, less than 180. Let's do one more together. What about RS? Look at that. That's almost 180, but not quite, so it's still a minor arc. So RS. All right, I'm gonna pause the video. Actually, I'm not gonna pause it. Go ahead and pause the video, see if you can fill out the other three, and let's see if we come up with the same ones. Okay, welcome back. I said QU, and I said UR, and then I also said US. Now, notice, look, US, notice I just took the SU and I flipped it. Okay, even when you rearrange the names, that still counts as a different arc. Oops, and does everybody see the mistake I made? Forgot this arc. Right, US. All right, so now let's go ahead and do semicircle. Now, semicircle is going to be this one right here. So semicircle is going to be equal to 180. And we also have to use 3 letters this time. So let's see if we can come up with some semicircles. What about RUT? Whoa, hang on. Okay, what about RUT? Notice that I passed the Q. My ultimate goal is to go from R to T, right? But I just have to pick any one of these points. It doesn't matter. I could have said RQT, but I'm going to go ahead and use RUT. RUT, that's half a circle. Okay, let's do the other half of the circle. If RUT works, then why can't I do RST? Okay, go ahead and pause the video and see if you can do one on your own. Okay, hopefully you got yours correct. Yours might not be the same as mine, but that's okay. So I did QUS. So look, Q to U to S. I could have said QTS as well, or STQ, or any sort of variation, so long as it's a semicircle. Now let's do the last one, and let's do major arc. Let me erase this. Let's start with this blue one. Now remember, major arc is more than 180, but less than 360. So not the whole circle, but almost. So QUR, look at this. QUR. Now, you're always trying to go the shortest possible distance. So from Q to U, what's the shortest way to U? Over here. Okay, and then now I got to go from U to R. Now what's the shortest way to U to R? Except for I can't overlap. So look, I cannot go back this way. You cannot do that. You have to keep going the same direction. So look at this, Q to U, and then from U to R. Notice how it takes up almost the whole circle, but it's more than 180, but less than 360. So Q, U, R. Okay, and let's go ahead and do another one. What about RUS? Look at this. I can take from R to U to S. Okay, that's a major arc, more than 180, but less than 360. RUS. Okay, go ahead and pause the video, see if you can come up with your own. Okay, I went ahead and did RSU. So look, I went R to S to U. All right, let's go ahead and continue. Got to pick up the pace a little bit here. Okay, so let's go ahead and take a look at this. This is talking about our central angles now. So look at this. This degree right here we know is going to be 90. All right, and then we know that this piece right here, this central angle right here is going to be 103. Now, you might be thinking, since this is 103, vertical angles 103, except for this is not the case. Now, oops. This is what makes circles a little bit confusing, is that this, you see WY? WY is not exactly a semicircle, meaning it doesn't make a line, meaning it's not 180. So we cannot say that those are vertical, but we do know that since this is 90, this one also has to be 90, okay, because this is a semicircle right here. So we know those need to be 90. But if we know that, then we know that this blue arc plus this green arc make a line as well. So we know they also have to be 180, right? So then we can do 180 minus 103, which gets us 77. Okay? That's a 77. Let me fix it. 77. All right, so now let's go in and take a look at these answers. We're looking for WX. So WX is going to be this arc. Now, if the central angle is 90, then we know that the arc measure is also 90. So then this one is going to be XY. Remember, Always looking for the shortest possible distance. So xy gets us right here, which is if the central angle is 77, we know that the arc measure will be 77. They're always equal. Okay, now let's do wy. Look, how do I know to go, not to go, or what if I were trying to solve this and I went this way? Now, this is a problem because this is not the shortest possible way. Notice that this is 90 plus 103, which is longer than going the opposite way. So then look at this. If I go this way, then it's only 90 and 77, which is shorter. So we have to add up 90 plus 77 to get us 167. And let me show my work real quick. Add these, 167. Okay, very good. Now let's take a look at another one. What about if we have, take a look at number 4. What if we have 3 letters? Okay, I'm going to go from W to X. Always do the shortest possible way. So I'm going to go from W to X. Okay, then I got to go from X to Z, but since I'm going this direction, I have to keep going the same direction. So from X to Z. So look at this. I cover all of these except for this 90. So then I have to add all these numbers together. If that's 103, we know this is 103. So I'm going to add all those numbers together. And when you add all those 3 numbers together, you get 270. Now you could have also, since we're not including this 90, you could have just done 360 minus the 90. But I decided to just add them all up. All right, let's do one more together and then you try one on your own. We're going to do YZW. So that's 103 plus 90. 193. Okay, go ahead and pause the video and see if you can do the rest on your own. All right, so I hope you were able to get these correct answers. If not, you could come to tutoring or just replay the video and see if you'll understand it the second time around. But we need to move on because we only have 3 more minutes left. Okay, arc length. We're going to go ahead and use this formula. This is new, and there's something new here. Okay, where it's going to be 2 pi r, which is just our circumference formula, where r is our radius. And then theta is going to be new. Theta is the measurement of the central angle. So all we have to do is plug it into the formula. We will be leaving things in terms of pi, but I will show you that in number 1. So number 1. Here we need to figure out what the central angle is. The central angle is going to be 60. So then we know that our arc length, which is this arc right here, is going to be 60. And this is going to be our theta. Now, look at what the question asks for. Find the arc length of the shaded portion. So I'm looking for this green line right here. So I know that the theta is going to be 60 and that r is going to be 3. Now, the radius is 3 and the theta is 60. So let's go ahead and plug it into our formula. So we're going to do 2 times pi times the radius times theta, all divided by 360. Now, we're going to be leaving things in terms of pi, so I'm going to go ahead and pull out this calculator. Now, remember, you can get this calculator software for free. If your teacher hasn't shared the link, then go ahead and message them or look at your Google Classroom because the link should be somewhere. Okay, so we're going to use our calculator. Now, we're leaving things in terms of pi. So look, you see this pi right here? I'm going to go ahead and ignore this pi. I'm going to do 2 times 3 times 60 divided by 360. Let's do that. So 2, we're going to do control divide 2 times 3 times 60. I did not type the 2. 2 control divide 2 times 3 times 60 over 360. Enter 1. So then our answer will be 1, and you leave your pi. So 1 pi. So let's go ahead and try the next one, but take a look at this one. Okay, so this one is a little bit different because they give you the diameter. So I found the radius, which is half the diameter. So if the diameter is 12, the radius is 6. Theta is going to be half a circle, so it's 180. I plug it into the formula, Remember, in the calculator, I'm just going to ignore the pi.